potential satellites where a lot of R&D is being invested in order to provide these measurements. You see the three circles here. On the left-hand side, the green circle or the green orbit, which underlines the science missions. So really satellites which are addressing questions of science. And we are developing cutting-edge technology in order to address these questions of science to answer some very important points which are being raised by the scientific community. Let's take an example, climate change. Scientists have asked us to monitor closely what is the extent of ice coverage, not only the extent of ice coverage, but the volume of ice on the polar regions and what is their change over time. And we have developed a satellite which is doing exactly that, to monitor regularly ice coverage on a daily basis. The second orbit is the Copernicus orbit, which symbolizes those satellites which we call sentinels that are monitoring the planet through the Copernicus program. The Copernicus program is a newer program within the agency, but a very substantive one, because we are doing this with the European Union, who has declared formally Copernicus as one of the two flagship programs in Europe. And together, the European Union, with the European Commission and the European Space Agency, we are developing a suite of satellites which are monitoring the planet from various angles with various instruments, and I will explain that a bit more in detail in a minute. And on the right-hand side, we have the meteorology missions, where we are building, together with EUMETSAT, which is the equivalent of NOAA in Europe, satellites for weather monitoring, weather observations, both in geostationary orbit and in polar orbiting orbits, in order to really see the various aspects of weather and climate parameters. Talking of space and observing the Earth, this is a very good example of the very first image. It's a TIROS satellite, which is a US satellite, which did monitor the Earth in 1960. On the 1st of April, the satellite was taking this first television picture from space. You see the New York Times article which is referring to it as really a new era in meteorology which has started with this launch of this satellite. A few years later, now, we are also having satellites observing the Earth for climate and weather purposes. Here are some examples that are measuring and observing constantly the state of cloud coverage, but also other weather parameters through both Meteosat, which is the geostationary satellite, and METOP, which are the polar orbiting satellites, which are going around updating the weather services with this type of information. What you see here is a very good example of how satellites work in daily life. In this case, you see Superstorm Sandy, well known in the United States. It was actually a storm that caused quite a few tens of casualties. First in the Caribbean, where you see at the bottom the start of Superstorm Sandy. The storm then went northwards, and at some point of time, meteorological services expected that the storm would turn towards Europe, to the east, and therefore not cause a danger for the Washington, New York area. However, as you see, the actual course of the storm, which is on the right-hand side, showed that the Superstorm Sandy went into the northeastern parts of the American continent and really caused, again, damage, but also casualties at this point of time. Of interest is the image in the middle, which shows these various lines in different colors, which are the forecasts of the path of the storm a few days in advance. In this case, 9.5 days in advance. And you see that there was a wide variety of where the storm will end up. Very few actually indicated